Question 36, 5 marks. 14.7 grams of solid sodium hydrogen carbonate was reacted with 120 ml of 1.50 moles per liter hydrochloric acid in a calorimeter. The temperature of the solution before and after reaction was recorded. Assume that all CO2 produced is lost from the reaction solution and that the specific heat capacity of the reaction solution is 3.8 J per Kelvin gram. What is the enthalpy of reaction in kilojoules per mole? So this is quite an interesting question because it brings in limiting reagent, Q cups NCAT, kilojoules per mole. So let me break it down for you. The first thing I did was to write a balanced chemical equation. So you have sodium hydrogen carbonate solid plus hydrochloric acid aqueous, which makes sodium chloride aqueous and carbon dioxide gas and liquid water. It turns out everything is already balanced as is. We are given the mass of sodium hydrogen carbonate as 14.7 grams. The molar mass is 84.008 grams per mole. The volume of hydrochloric acid is 120 ml with the concentration of 1.50 moles per liter. It also supplied a density which is 1.02 grams per mil. And then the specific heat capacity of the reaction is 3.80 joules per Kelvin times grams. The temperature of the initial reaction is 21.5 Celsius. Final temperature of the reaction solution is 11.5 Celsius. Now another equation we need is the relationship of delta H to Q, which is delta H is minus Q divided by N. First thing is to find the limiting reagent. Now in a 1-to-1 ratio comparison, we can tell that sodium hydrogen carbonate is the limiting reagent. The next thing we need to do is to factor in Q equals MCAT. Now the mass of the reaction is the total amount. So we have mass from sodium hydrogen carbonate. Density was given for hydrochloric acid, so let's work that out. It's going to be 14.7 grams, which is the sodium hydrogen carbonate, plus the contribution of hydrochloric acid, 1.02 grams per mil, is the density. Multiply that by 120 mil, we can get the mass. Everything's 1:1. The mass of carbon dioxide is 0.175 mole times the molar mass of carbon dioxide. So the total mass of the reaction, 129.4. And now we're going to put it back to the Q cups NCAT and work out what Q is. Q is 4,917.2. Simply transform that into kilojoules, so just divided by 1,000. Negative 4.917 kilojoules. Enthalpy of the reaction in kilojoules per mole. Q is simply negative 4.917 kilojoules divided by 0.175 mole. The answer is then plus 28.09 kilojoules per mole. So this is an endothermic reaction. Thank you for watching. Please like and subscribe to this channel for more quality contents. I'll see you next time.